Hello everyone and welcome to the 2026 World Engineering Day WFEO Hackathon Finalist Showcase. The 2026 World Engineering Day WFEO Hackathon is held as part of the celebrations of World Engineering Day for Sustainable Development and is focused on young engineering students. It is an opportunity to showcase young engineers' talents around the world in solving some of the UN Sustainable Development Goals through engineering. The theme for the 2026 World Engineering Day WFEO Hackathon is Smart Engineering for a Sustainable Future through Innovation and Digitalization. This year has been our biggest yet, with over 3,000 registrations, 270 submissions, and more than 9 million people reached globally.
Wow, that is seriously extraordinary. What a great achievement. It reflects the passion, creativity, and global collaboration of thousands of engineering students and young innovators who are working tirelessly to advance the United Nations Sustainable Development Goals. Tonight, we recognise the top teams who have demonstrated excellence in innovation, feasibility, impact, and their alignment with UN Sustainable Development Goal 9, Industry, Innovation, and Infrastructure.
The 2026 World Engineering Day WFEO Hackathon challenged teams to demonstrate how engineering and digital technologies can build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation that benefits both people and the planet.
In addition to UN Sustainable Development Goal 9, our challenges also align with Goal 11, Sustainable Cities and Communities, Goal 12, Responsible Consumption and Production, Goal 14, Life Below Water, and Goal 15, Life on Land. The quality of the submissions made judging incredibly competitive.
It is now our great pleasure to introduce the top 11 finalist teams of the 2026 World Engineering Day WFEO Hackathon, showcased in alphabetical order.
First up, it's Aeromax from Batangas State University in the Philippines. They're tackling Challenge 1, Circular Innovation.
Every year, we celebrate the newest device.
A faster phone, a thinner laptop, a smarter screen.
But we rarely ask the question that matters most.
What happens to the old ones?
In 2022 alone, 62 million tons of electronic waste were thrown away and ended up in landfills, 7.8 kilos per person.
The rest releases toxic chemicals into the soil, the air, and the water, costing governments billions just to contain the damage. And at the same time, agricultural waste piles up. In the Philippines, one of the world's largest banana exporters, banana peels are thrown away by the ton, every single day. Waste everywhere, clean water almost nowhere.
But waste is not useless. As chemical engineers, we learn something powerful. Materials don't die, they transform. Using a selective etching process, we recover valuable components from electronic waste and give them a second life. From banana peels, we extract strong natural fibers. Together, they form a lightweight material that floats in water, absorbs sunlight, and does something remarkable. It turns seawater into clean, drinkable water.
No electricity, no fuel, just sunlight. We call this project Maxine CNF Aerogel Composite.
In the Philippines, 59 million people still live without reliable access to clean drinking water. For them, water is not a convenience. It is a daily struggle. Our project is designed for these communities. With our composite serving as the core innovation in desalination systems powered by waste and the sun, the system offers the potential to produce up to 100,000 liters of potable water every day at virtually zero operating cost and just 0.3 cents per liter, enough to supply clean water to up to 250 households daily. The material also naturally helps limit harmful microbes, making water safer to drink. This is not just technology. This is dignity. This is health. This is time returned to families.
The system is simple because it has to be. No complicated machines, no expensive infrastructure. Modular panels that can be placed where water is needed most. Coastal areas, rural communities, and disaster zones. And while we begin with banana peels, the idea goes further. Any local plant-based waste can become a part of the solution. Local waste, local water, global impact.
Aligned with SDG 6, 9, and 12, this modular decentralized system transforms local waste into durable Maxine CNF aerogel panels for homes, coastal areas, and remote communities. Beyond water production, it reduces landfill waste, lowers emissions using solar energy, and creates value from discarded materials.
Risk is addressed by design. Closed-loop Maxine synthesis ensures safety. Encapsulation enhances durability. Modular Maxine CNF aerogel panels enable reliable scale-up. This is what responsible production looks like. This is how innovation builds infrastructure, not from extraction, but from smarter use. We don't need more waste.
We don't need more pollution. We need better ideas.
We need Maxine CNF aerogel composite.
Because every Filipino deserves access to clean water.
And sometimes, the solution isn't something new. It is something we were throwing away all along.
Next up, Algaboard from Ewha Women's University, South Korea, tackling Challenge 1, Circular Innovation.
As global sewage production continues to grow alongside climate change, increasing volumes of discarded sewage are placing pressure on coastal environments and industrial systems. This challenge is observed both in major sewage-producing countries such as South Korea and worldwide coastal regions experiencing large-scale natural sewage accumulation. Today, global sewage production exceeds 37 million tons annually, yet management and recycling systems remain fragmented. As a result, large amounts of seaweed biomass are still left untreated or landfilled, not fully used. Our project addresses this challenge from an engineering perspective. Rather than framing seaweed outside its primary use as waste, we aim to convert it into standardized, industrially feasible circular resource.
Our solution, Algaboard, upcycles waste seaweed into construction materials. The waste seaweed is sourced from two main origins: byproducts from local seaweed processing factories or seaweed collected from areas affected by excessive seaweed proliferation. In the first processing step, the collected seaweed undergoes washing and desalination. It is initially immersed in purified water for a certain period to reduce salinity, followed by mechanical washing to remove remaining impurities and salt residues. Rather than discharging the used washing water, the system incorporates a solar-powered seawater desalination system to reuse the water for subsequent washing cycles. Next, excess moisture is removed using a press-type dewatering machine, and after that, the seaweed is naturally air-dried outdoors. Depending on weather conditions, an indoor hot air drying system can be used as a supplementary method. Once dried, the seaweed is shredded into smaller particles, and biopolymers are added as natural binders to improve cohesion. Now, the mixture is formed into boards using a hydraulic press. To enhance durability and expand potential applications, the boards are finally coated with a bio-based protective layer. All processes are supported by solar power, eliminating reliance on external power sources while minimizing environmental impact.
Digitalization is applied in two stages: the drying process and the quality evaluation. While drying seaweed, the system continuously tracks the key properties such as mass, moisture, and temperature using sensors. Based on this data, it automatically optimizes the drying conditions to match the current state of the material. Once fabrication is completed, the board undergoes resonant frequency analysis. Upon a mechanical impact, the resulting vibration response is recorded. This signal is then converted into the frequency domain to identify key characteristics such as resonant frequencies and damping behavior. These results are fed into a machine learning model, which uses the pattern in the data to assess stiffness, internal voice, and density variations, all in a non-destructive way.
Based on prior research, our solution has been proven to be effective. When compared to materials with similar applications, MDF and polystyrene, its density, thermoconductivity, and Young's modulus indicate it's a promising material combining the advantages of both MDF and polystyrene. According to the study, it also shows similar humidity resistance to polystyrene, which is a clear advantage in coastal environments. In addition, it has a good inherent fire retardant, making the board suitable for insulation use. As a result, our Algaboard is well suited for a wide range of infrastructure in coastal regions, including insulation materials, temporary structures such as fish market facilities, and interior wall panels. By introducing a new approach to utilizing waste sewage, this project contributes to circular resource innovation.
By reframing sewage from a conventional waste pathways into an industrial use, we create environmental and social value. The essential setup requires an investment of around 25,000 euros, which is relatively manageable at an industrial scale. Our project aligns with SDG 9 via smart processing system, which is adaptable to local industrial conditions and designed to remain resilient under various fluctuations. The project also strongly supports SDG 11 by enabling building more sustainable urban communities with locally available sources. In addition, it contributes to SDGs 12, 13, 14, and 15 by lowering life cycle emission and easing pressure on ecosystems. Engineering a more resilient and circular future, starting with Algaboard.
What an interesting solution. Well done. Next up, we have Digital Guardians of the Biofrontier from SRM Institute of Science and Technology in India. They're tackling Challenge 3, the blue and green planet.
Humanity is at crossroads. While we have achieved unprecedented industrial wealth, 7 of our 9 planetary systems are now in overshoot. We are effectively flying the planet blind. Traditional conservation is stuck in an analog past, relying on manual surveys that can't see through dense forest canopies or beneath the ocean surface in real time. Today, representing the digital guardians of the biofrontier, we present the solution that uses smart engineering to rebalance on land and life below water. We aren't just saving trees, we are upgrading the world's environmental infrastructure to match the intelligence of our industrial ones. What's missing is not intent, but intelligence. Our planet generates signals every second, stress imbalance, warning, but we lack the digital nervous system to listen at scale. Climate isn't just an environment crisis. It's a data crisis. Engineering gives us the power to see invisible, hear the unheard, and act before damage becomes irreversible. This is not about choosing development over nature, it's about engineering a future where both can thrive together.
To operate at true planetary scale, each biomass node is designed for extreme autonomy. Energy harvesting through microsolar and kinetic sources enable multi-year deployment without human intervention. The system support over-the-air AI model updates, allowing continuous learning as new environmental threats emerge. This means the network doesn't just survive harsh ecosystem, it evolves with them, delivering a future-proof digital backbone for environmental intelligence. Our innovation centers on the biomass node, a decentralized AI-driven edge computing device. Unlike traditional IoT sensors, these nodes process data locally, only sending alert when a true threat is detected. This smart edge approach saves 90% of energy compared to a standard system. Looking at our architecture, these nodes form a self-healing mesh network. If a node in a harsh environment is destroyed, the data instantly reroute through others, ensuring 100% uptime. This is the backbone of a resilient digital frontier that monitors what digital miss.
Hey, can you explain about technical specs and SDGs?
Oh yeah.
Okay, so technically the biomesh is a multi-sensory powerhouse. Its acoustic air identifies the specific frequencies of chainsaws for SDG 15 or blast finishing for SDG 14 within a 2.5 kilometer radius. Meanwhile, its chemical telemetry provides real-time monitoring of pH, salinity and dissolved oxygen in marine dead zones. We have also engineered the hardware for the circular economy. The housing is crafted from mycelium-based composites or recycled marine plastic, ensuring that very tools we use to protect the earth do not contribute to its degradation. So, by this way, we can able to think about technical specs and SDGs and its various factors affecting the technical specs and SDGs and its cause and its preventions. Thank you.
Data is not just the only option. We also need a lot of foresighting. In the past, we would only react when an ecosystem collapsed. Today, we bridge this gap with the help of an ecosystem digital twin. With the help of certain data nodes inserted into machine learning models, we can just identify and help in interpreting decades of climatic impacts in just a few seconds. We can just identify certain tipping points and intervene before they can just act out. This will just redirect our approach from social cleaning to proactive persuasion and preservation. So basically, our project not only solves this very challenge, but it also helps us question our existence and how much stable it will be in the upcoming years. I would just like to end by saying that from overshoot to regeneration, we are the digital guardians of the biofrontier. Thank you so much.
That was an impressive solution. Next up, we have Green Core Sustainable Data Center from Shanghai Jiaotong University, China, tackling Challenge 1, Circular Innovation.
With the rise of generative artificial intelligence, computing power has become a rapidly emerging source of electricity demand in recent decades. Yet, the surge in intelligence carries a heavy environmental price. We apply a bottom-up material flow analysis framework to evaluate the environmental footprint of data centers worldwide. By 2025, data centers worldwide consumes over 550 terawatt-hours of electricity, emitting more than 200 million tons of carbon dioxide. Their water footprint is equally alarming.
8 million cubic meters of water are used for cooling, and another 3 billion for power generation.
We now face a paradox. How can we power the intelligence of tomorrow without draining the resources of today?
Our answer is an intelligent power water thermal co-optimization system for data centers. Built on a 3-layer prediction, decision, control architecture, we make effort to make every server not only smarter but greener.
The prediction module forecasts power demand, grid stability, and thermal health support of data centers by training a large language model on data center workload patterns and historical grid data. The decision module then generates optimized strategies using reinforcement learning to balance energy usage, server cycling, and workload scheduling. The control module applies these strategies by directing infrastructure to respond in real time while monitoring feedback to sustain adaptive operation that supports energy and water efficiency. For energy conservation, we find that uninterruptible power supplies for UPS systems are inevitable energy consumers. To guard against grid fluctuations, UPS systems remain online throughout the year to provide stable power for data centers. However, when the grid is operating normally, this extra rectification and conservation is not strictly necessary. Thus, our prediction and decision module help to equip the UPS with its own digital brain, enabling switch from always-on design into dynamic anticipation mode. The prediction module allows to predict short-term demand and grid stability. When a grid is stable, the decision module helps to shift the UPS into a light load eco mode, cutting internal losses by up to 70%. When a disturbance is predicted, it switches back to full load mode in advance, quietly ready before risk arrives.
For material conservation, we find that data centers rely on massive battery systems rich in lithium, cobalt, and nickel. Aggressive cycling to save energy often shortens battery life, driving more mining of critical materials. Our system introduced battery life degradation as an optimization penalty term in the reinforcement learning. By balancing state of charge, temperature, and discharge rates, batteries stay in their optimal operating range, extending equipment life and reducing resource use.
For water conservation, cooling is why data centers are thirsty. Instead of blindly flooding rooms with cold air, our prediction module generates a hotspot risk map. Based on this forecast, our decision module dynamically reallocates workloads and stair flows. By replacing traditional floors with air guarding plates and adjustable vents to direct air straight to server inlets. Together, these sections cool hotspots faster, spread heat more evenly, and reduce overheating risks, while boosting cold air utilization from 60% to 90%.
Our system also integrates a rooftop solar storage system to lower carbon intensity and optimize cost effectiveness. We integrate translation between human-defined requirements and machine-readable rules in the decision module, allowing these constraints to encode as a reward function for reinforcement learning agent, and eventually helps data centers to generate optimal energy consumption strategies, such as pre-cooling during low-price periods and arbitraging at electricity price peaks.
Together, these three modules answer the core of the United Nations Sustainable Development Goals. They support SDG 7 for clean energy, SDG 11 for sustainable cities, SDG 12 for responsible consumption, and SDG 13 for climate action. In the future, data centers will no longer be black boxes that devil electricity and water. They will be smart organs of our infrastructure, highly efficient, resource-aware, and life-extending. As our digital world expands, our planet will breathe easier. Let every kilowatt-hour be smarter, and let green power flow to the very heart of computing.
Fantastic innovation in action. Next up, we have Methanogen Z from Batangas State University in the Philippines. They're tackling Challenge 2, Resilient Cities.
Every typhoon exposes a deeper truth, not just about the climate, but about what we ignore. Scientists warn that the rising global temperature are fueling stronger typhoons across Southeast Asia. Warmer oceans, higher sea levels, and storms that hit harder and last longer. Climate change does not happen on its own. Methane and other greenhouse gases trap and heat in the atmosphere, accelerating warming, intensifying rainfall, and turning storms into disasters. Every emission we neglect today fuels the disaster we face tomorrow. The Philippines generate nearly 3 million tons of food waste every year. That is 8,000 tons every single day. When the waste decomposes anaerobically, it emits methane, a greenhouse gas 84 times more potent than carbon dioxide over a 20-year period. Globally, methane emission now exceeds 580 million metric tons annually, with the waste sector as one of the fastest and most preventable sources.
Existing biodigesters fail for three reasons: high capital and centralization, complex operation, and dependence on electricity. Methanogen Z transcends all three. It is a mobile, modular, and manual food waste digester designed for decentralized deployment. Food waste and water are mixed and sealed in an airtight chamber where anaerobic microbes convert organic waste into biogas within 15 to 30 days. The biogas, composed mainly of methane and carbon dioxide, passes through a 4-stage dry scrubbing system where impurities are removed. The clean biomethane is used for cooking and small-scale energy needs, while captured carbon dioxide remains within the system, becoming part of the nutrient cycle. The remaining digestate enriched by this process is recovered as biofertilizer and applied directly to crops. Petchai fertilized with the digestate showed a 30% increase in growth, demonstrating a closed-loop circular economy where waste becomes energy and byproducts return to the soil to grow food. Fully off-grid, locally maintained, and disaster-ready. Methanogen Z scales horizontally from households to barangays to bustling cities.
If 20% of Filipino households adopt, that's removing 120,000 tons of methane, an equivalent of removing 730,000 cars from Philippine road. We built Methanogen Z to be fully off-grid, mobile, modular, and disaster-ready. From remote villages to cities, our solution scales easily and adopts anywhere. It closes the smartest loop at the community level. Food waste is no longer discarded, it is recovered. Energy is no longer centralized, it is produced locally. Fertilizer is no longer imported, it is returned to the soil. And the impact speaks for itself. With a single unit, it can empower 1,440 households, a savings of $300 per household in LPG use every year. Food waste becomes biofuel and biofertilizer in a closed-loop system. And it's already begun. We're communicating with local government units because real ownership starts at the grassroots, with the people. We've already done concept testing to see how the system fits their needs and everyday reality. This is climate justice, Filipino-led, community-owned. At its core, the mobile food waste digester is more than a machine. It's a lifeline, a solution designed not only to combat waste but to uplift communities and reach the people who need it most. Methanogen Z intervenes before disaster becomes normal, before methane becomes irreversible. By enabling decentralized biogas from food waste, by preventing methane emission at the source, by reducing landfill pressure and urban waste impacts, by aiding soil health with biofertilizer, and through circular waste-to-energy system. From food waste to biogas and biofertilizer, Methanogen Z is designed for a smarter urban system for a livable future.
The future! We're defining the future! We're defining the future!
Redefining the future!
Redefining the future!
Wow, that was a thoughtful and impactful submission. Coming up next, we have MicroGuard from King Mongkut's Institute of Technology, Thailand, tackling Challenge 3, Blue and Green Planet.
และตอนนี้นะคะพวกเราก็ได้ยืนอยู่ที่หาดวรรณภาบางแสนน้ำอาจจะดูใสแต่สิ่งที่ทุกคนมองไม่เห็นคือไมโครพลาสติกที่ปนเปื้อนมาจากขยะและอยู่ในน้ำทะเลค่ะปัจจุบันในมหาสมุทรทั่วโลกพบไมโครพลาสติกมากกว่า170ล้านชิ้นและยังเพิ่มขึ้นในทุกๆปีเนื่องจากขยะจากพลาสติกที่ใช้ในปัจจุบันค่ะนั่นหมายความว่าปัญหานี้ไม่ใช่ปัญหาของทะเลแต่เป็นปัญหาของสุขภาพมนุษย์รวมถึงเราที่อยู่ตรงนี้ด้วยค่ะถ้าไมโครพลาสติกยังคงถูกปล่อยไว้แบบนี้ในทะเลไมโครพลาสติกจะถูกแพลงก์ตอนกินเข้าไปจากนั้นส่งต่อไปยังปลาสัตว์ทะเลและสุดท้ายกลับมาที่มนุษย์ผ่านอาหารทะเลที่เราบริโภคเมื่อมันเข้าสู่ร่างกายงานวิจัยพบว่าไมโครพลาสติกสามารถสะสมในลำไส้ปอดและตรวจพบได้ในเลือดของมนุษย์ซึ่งอาจรบกวนการทำงานของระบบภูมิคุ้มกันและเพิ่มความเสี่ยงต่อการอักเสบในระยะยาวในระดับสิ่งแวดล้อมไมโครพลาสติกทำหน้าที่เหมือนฟองดูดสารพิษดูดซับโลหะหนักและสารเคมีอันตรายจากน้ำทะเลทำให้ความเป็นพิษทวีคูณเมื่อเข้าสู่ห่วงโซ่อาหารจากปัญหาที่เราพบเราจึงตั้งคำถามว่าถ้าไมโครพลาสติกเล็กเกินกว่าระบบกรองทั่วไปจะจัดการได้เราจะตรวจจับและดักจับมันได้ยังไงและในการแก้ปัญหาของทางทีมเราก็มีทั้งหมด3อย่าง PTT 1. P Protect Marine Life ปกป้องสิ่งมีชีวิตทางทะเล 2. T Track Sources of Microplastic ติดตามและตรวจสอบแหล่งที่มาของไมโครพลาสติกและ 3. T Thai Lister Ocean to Healthy Condition ฟื้นฟูมหาสมุทรให้กลับมาอุดมสมบูรณ์และมีสุขภาพที่ดีค่ะ
ทีมของเราจึงพัฒนาระบบต้นแบบที่สามารถทำงานได้2อย่างพร้อมกันอย่างแรกคือการดักจับไมโครพลาสติกด้วยกระบวนการทางกายภาพและอย่างที่2คือการตรวจจับและวิเคราะห์ข้อมูลด้วยเทคโนโลยี AI แนวคิดของเราคือการจัดการไมโครพลาสติกตั้งแต่ต้นทางก่อนที่จะไหลลงสู่ทะเลและสะสมในระบบนิเวศครับ เราเริ่มจากการทดลองจริงโดยเตรียมน้ำตัวอย่างที่มีไมโครพลาสติกเพื่อจำลองสภาพแหล่งน้ำธรรมชาติให้ใกล้เคียงกับการใช้งานจริงมากที่สุดจากนั้นสูบน้ำเข้าสู่สถานีดักจับให้น้ำไหลผ่านชั้นน้ำมันซึ่งทำหน้าที่ดักจับไมโครพลาสติกโดยอาศัยคุณสมบัติทางกายภาพของน้ำมันที่สามารถยึดจับอนุภาคได้ดีเราทำการเปรียบเทียบน้ำก่อนและหลังผ่านระบบเพื่อประเมินประสิทธิภาพการดักจับผลการทดลองพบว่าระบบของเราสามารถดักจับไมโครพลาสติกได้ถึง 90-95% ต่อรอบการทำงานและน้ำมันที่ใช้สามารถนำกลับมาใช้ซ้ำได้ประมาณ 5-10 รอบโดยที่ประสิทธิภาพการลดลงเพียงเล็กน้อยหลังจากผ่านขั้นตอนการดักจับน้ำจะถูกส่งต่อเข้าสู่ระบบกรองขั้นสุดท้ายโดยเราใช้ตัวกรองนาโนพอรัสคาร์บอนเพื่อดักจับอนุภาคขนาดเล็กที่อาจหลงเหลืออยู่และช่วยดูดซับสารปนเปื้อนเพิ่มเติมครับหัวใจสำคัญที่ช่วยยกระดับการดักจับของเราคือนาโนพอรัสคาร์บอนโดยเราเปลี่ยนลิกนินที่เป็นของเสียจากอุตสาหกรรมให้เป็นวัสดุที่มีมูลค่าสูงด้วยกระบวนการคาร์บอเนเซชันที่อุณหภูมิ 7 องศาเซลเซียสความโดดเด่นของวัสดุของเราคือการที่วัสดุของเรามีพื้นที่ผิวจำเพาะสูงถึง 1,000 ตารางเมตรหรือเทียบเท่ากับสนามฟุตบอลขนาดเล็กได้ผงคาร์บอนเพียง 1 กรัมโครงสร้างรูพุนระดับนาโนนี้เองทำให้สามารถดักจับไมโครพลาสติกขนาดเล็กให้มีประสิทธิภาพในการดักจับถึง 90-99% ก่อนปล่อยน้ำคืนสู่ธรรมชาติครับหลังจากการดักจับเรานำเทคโนโลยี AI Computer Vision มาใช้ตรวจจับไมโครพลาสติกแบบเรียลไทม์ระบบของเราจะแสดงจำนวนไมโครพลาสติกระดับมลพิษทางน้ำและเปอร์เซ็นต์การตรวจพบข้อมูลทั้งหมดจะถูกนำไปวิเคราะห์แนวโน้มผ่านแดชบอร์ดและสามารถสรุปเป็นรายงานย้อนหลังเพื่อให้ใช้ในการเฝ้าระวังและตัดสินใจในเชิงนโยบายหรือการจัดการพื้นที่ได้ครับ
การเชื่อมโยง SDG และความยั่งยืนนวัตกรรมไมโครการ์ดไม่เพียงแต่แก้ปัญหามลพิษแต่ยังตอบโจทย์เป้าหมายที่ยั่งยืนถึง 3 ด้านหลักด้วยกันค่ะได้แก่ 1. SDG 12 เราขับเคลื่อนเศรษฐกิจหมุนเวียนโดยการนำของเหลือทิ้งทางเกษตรมาสร้างเป็นนวัตกรรมใหม่ 2. SDG 6 และ 14 เราปกป้องระบบนิเวศทางทะเลและแหล่งน้ำจืดจากการปนเปื้อนเพื่อความมั่นคงทางอาหารและสุขภาพของมนุษย์ในระยะยาวค่ะ 3. SDG 9 เป็นการสร้างมาตรฐานใหม่ในการติดตามคุณภาพน้ำด้วย AI Vision และวัสดุนาโนค่ะ
และอันดับหนึ่งที่ตรงกับงานของกลุ่มพวกเรามากที่สุดคือ SDG 14 และ SDG 15 เป็นตัวเลือกที่เหมาะสมที่สุดสำหรับวัตถุประสงค์หลักของโครงการ SDG 14 คือเป้าหมายหลักของผลงานเพราะระบบออกแบบมาเพื่อดักจับไมโครพลาสติกในแหล่งน้ำชายฝั่งและกระชังเพาะเลี้ยงสัตว์น้ำเพื่อปกป้องระบบนิเวศทางทะเลและลดการสะสมของพลาสติกในสระน้ำที่จะส่งผลเสียต่อมนุษย์ SDG 15 ครอบคลุมการจัดการปัญหาตั้งแต่ต้นทางในแหล่งน้ำจืดหรือพื้นที่ป่าชะเลนก่อนจะไหลลงสู่ทะเลค่ะ
และบทสรุปของเราไมโครการ์ดจึงไม่ใช่แค่เครื่องกรองน้ำแต่เป็นระบบอัจฉริยะที่พิสูจน์ว่าของเสียจากอุตสาหกรรมหนึ่งสามารถกลายเป็นหัวใจสำคัญในการรักษาโลกของเราไว้อย่างยั่งยืนค่ะ
Next up, it's Ionics from Batangas State University in the Philippines. They're tackling Challenge 3, the blue and green planet.
Every drop of water tells a story, but some stories are tragic. In contaminated rivers, aquatic organisms die. In polluted soil, terrestrial ecosystems collapse. Invisible metals, silent destruction. We're facing an ecological crisis. But what if we told you the solution is already in your kitchen?
Water contamination is not a distant problem. It's a crisis affecting ecosystem right now. Zinc contamination specifically from industrial discharge, mining operation, urban runoff, poisons our rivers, soil, and groundwater. It kills aquatic life. It contaminates soil. It destroys the ecosystem we depend on. In the Philippines, where we conducted this research, zinc levels in the Mekawayan River exceed safe thresholds by more than 2.5 times. This is our home. This is our ecosystem, and we have a responsibility to restore them.
We ask a fundamental question. What if we could protect entire ecosystems using waste? Billions of chicken bones are discarded every year. By transforming this agricultural waste into a resource, we accomplish two goals: reducing landfill impact on terrestrial ecosystems, protecting soil health and preventing land degradation, while creating a solution to clean water and protect aquatic life. These bones contain hydroxyapatite, a calcium phosphate mineral with a natural affinity for heavy metals.
We developed a process to extract and enhance this mineral, creating magnetic nanoparticles that can trap zinc ions and be easily separated using a simple magnet. This is not just efficient. This is ecosystem restoration through engineering.
The results validate our ecosystem restoration efficiency. Our testing achieved 91.25% zinc removal efficiency under optimized conditions. The maximum adsorption capacity reached 41.16 milligrams of zinc per gram of our material. This means a small amount of nanoparticles can treat large volumes of water. Our research identified that zinc removal follows the Freundlich isotherm model, indicating heterogeneous multi-layer adsorption. The more zinc present, the harder the material works. Most importantly, our nanoparticles retain 67.4% effectiveness over 4 complete adsorption-desorption cycles. This is not a one-time solution. This is a sustainable, reusable system.
This is more than a thesis project. This is ecosystem restoration at scale. Our solution directly addresses 2 critical sustainable development goals. By removing zinc and heavy metals, we restore aquatic ecosystems. Fish can survive, marine organisms can thrive, coastal biodiversity is protected. By transforming agricultural waste into a resource, we reduce landfill impact. We prevent soil degradation, we restore terrestrial ecosystems.
Based on cost analysis, our magnetic hydroxyapatite produced from agricultural waste cost approximately 200 to 900 pesos per kilogram, compared to 6,000 to 9,000 pesos per kilogram for conventional ion exchange resins, making it about 10 to 30 times cheaper on a material cost basis. Furthermore, due to its magnetic separability and reusability across multiple regeneration cycles, the life cycle treatment cost is estimated to be 50 to 200 times lower than conventional ion exchange systems, depending on operating conditions and regeneration efficiency.
This is not just solving a technical problem. This is restoring the ecosystems we've damaged, and we're making it accessible to every community. A small village in the Philippines can now restore its local water ecosystem, not with a $500,000 peso facility that only wealthy nations can afford, but with a cost-effective nanoparticle system that democratizes ecosystem restoration.
In our vision, we'll scale this from laboratory to pilot facilities. For in coming years, the first industrial installations treating coastal waters and soil systems.
In the future, communities across the countries will have their damaged ecosystems actively restored through a technology derived from as simple as chicken bones.
This is not a distant dream. The chemistry works. The data proves it. The sustainability case is undeniable.
The future of water is built on creativity, courage, and magnetic nanoparticles from chicken bones. And it's here, now.
Our next outstanding finalist is Sentinel Innovators from Chinoy University of Technology and Masvinjot Polytech, Zimbabwe, tackling Challenge 2, Resilient Cities.
Good day, judges, engineers, and distinguished guests. My name is Brighton Mutwaseko, representing Team Sentinel Innovators. Imagine a farmer standing in a field, holding a bag of fertilizer, unsure whether applying more will increase yields or silently degrade the soil and contaminate nearby rivers. This uncertainty drives fertilizer over-application, inefficient irrigation, and ecosystem damage. This directly impacts Sustainable Development Goals, that is SDG 12, SDG 14, and SDG 15. Today, we present RoboSoil, an autonomous solar-powered mobile soil intelligence platform engineered to deliver real-time in-field soil diagnostics and moisture prediction for smallholder farming systems. Smallholder agriculture forms the backbone of food production in Zimbabwe and across the global south. However, most farmers operate without quantitative soil data, relying on heuristics and experience rather than agronomic insights. Consequences are nutrient imbalance, inefficient water use due to non-optimized irrigation schedules, nutrient runoff and eutrophication of aquatic systems, progressive soil structure degradation, and fertility decline. Conventional soil testing laboratories are centralized, costly, and time-intensive, while existing precision agriculture technologies are capital-intensive and unsuitable for small-scale development. RoboSoil addresses these gaps through a cyber-physical agricultural system that integrates robotics, embedded electronics, sensing technologies, and data-driven decision logic. The platform is designed around three tightly coupled engineering layers.
Layer number 1, mobile sensing and actuation layer. In this layer, RoboSoil is an electromechanical soil probe houses calibrated sensors for soil pH, volumetric water content, macronutrient concentration, NPK. Layer number 2, embedded intelligence and data processing layer. Sensor signals are contained and discharged by an embedded microcontroller platform. Data is processed using rule-based nutrient sufficient modules, moisture retention estimation algorithms, parameterized by soil texture and current water content. This enables predictive irrigation scheduling and precision fertilizer recommendation, minimizing over-application while maintaining optimal crop nutrients. Layer number 3, communication and human-machine interface layer. Processed outputs are transmitted via Bluetooth or Wi-Fi to a mobile application dashboard. The interface provides multilingual farmer-readable recommendations, offline-first functionality for low connectivity regions, historical data logging for seasonal trend analysis. This transforms complex sensor data into actionable agronomic intelligence. Preliminary validation demonstrates stable sensor readings across varying soil samples, reliable moisture trends prediction under controlled conditions. From an impact perspective, irrigation water usage can be reduced by up to 30%. Fertilizer inputs are optimized, reducing nutrient leaching and runoff. Crop yields are projected to increase by 20 to 40%. Critically, by preventing excess fertilizer application, RoboSoil protects aquatic ecosystems from eutrophication, preserves soil integrity and land productivity. The project directly supports SDG 9, SDG 12, SDG 14, and SDG 15. RoboSoil is engineered using low-cost, locally sourced components, enabling local assembly and maintenance, deployment via farmer cooperatives, extension services, and NGOs, scalable service-based modules suitable for rural contexts.
In conclusion, RoboSoil operationalizes sustainable agriculture through engineering precision. By integrating robotics, sensing, embedded intelligence, and digital interfaces, the system replaces guesswork with data, enhances food security, and safeguards land and water ecosystems.
RoboSoil is not just a robot.
It is a platform for sustainable, data-driven farming. Thank you.
Next up, it's Team Ecologic from the Technological Institute of Philippines, tackling Challenge 3, the Blue and Green Planet.
Rice is the blood life of billions, but it is currently under a biotic siege.
Our farmers are fighting a losing battle against pests such as the brown plant hopper and the yellow stem borer. The data is clear. Unprotected rice farms risk losing up to 30% of their total yield to this pest. Bioprotection Portal also said that depending on the type of pest and when they attack, infestation can reduce yields by 20 to 100%.
To survive, farmers have entered an expensive trap of chemical reliance. In the Philippines alone, pesticide import values have surged from $30 million to almost $500 million in recent decades. Fortune Business Insights projected that the agricultural chemical market will hit $67.18 billion this year and will continue to grow to $97.01 billion by 2032.
But this reliance is a blind figure. As the Center for Biological Diversity reports,
pesticides harm soil invertebrates in 71% of cases, destroying the ecosystem engineers like earthworms that keep our soil alive. However, the consequences of this chemical dependency extend far beyond the field, creating a catastrophic impact on marine ecosystems. Approximately 80% of marine and coastal pollution originates from land-based sources, primarily agricultural runoff. When pesticides and fertilizers leach into water systems, they flow into coastal areas, triggering massive algal blooms that deplete oxygen, leading to areas called dead zones.
We built a better way. This is EcoEco, solar-powered ground-based structure designed to replace toxic chemicals.
Replace toxic chemicals with directed acoustic energy. The hardware operates on a minimal 5-volt supply, making it perfect for remote fields, and we've integrated it with a smart monitoring app.
Through the Echo app, farmers can monitor their fields in real time via the built-in camera, check the solar charging, and view a system log that identifies which pests are currently most active.
Our algorithm is already proven. In simulations, we've achieved high confidence detection of insects like the rice bug, allowing for precision management rather than blind spraying. Farmers have total control. They can switch the ultrasonic signal between static, dynamic, or automatic modes directly from their phone.
We aren't just prepared. We are disrupting the very life cycle of this pest and preventing apiculture.
When set to automatic, the system executes frequency sweep technology, cycling between 20 kHz and 40 kHz. Research by Sharawati confirms this range is highly effective at suppressing brown planthopper populations. For leafhoppers, we emit frequencies at 40 kHz to jam their acoustic communication. Puriono's 2023 study demonstrated that this jamming led to a reduction in pests over a time period of hours or days. A single unit creates a 75-meter virtual fence of protection. As Estacio verified in the Manila Bulletin, these deterrents are fully capable of protecting vast areas with a zero carbon footprint.
But here is where the data gets exciting. EcoEco doesn't just protect the crop, it enhances it.
We've shifted the device from a pest repeller into a yield enhancer. The sound waves actually increase the permeability of plant cell membranes. Research published in the Botanica Journal of Tropical Agricultural Science confirms that specific sound frequencies improve nutrient and water uptake.
This results in recorded yield increase between 5.7% and 11%. The farmer isn't just saving money on chemicals, they are producing more rice per hectare. By implementing EcoEco, we provide a direct path towards achieving SDGs 14 and 15. We are fundamentally changing how we interact with our environment.
For SDG 14, Life Below Water, we are eliminating the source of land-based agricultural runoff. By removing chemicals from the equation, we stop the nutrient leaching that creates hypoxic dead zones, protecting marine biodiversity and the livelihoods of 3 billion people.
For SDG 15, Life on Land, EcoEco acts as an non-invasive protector. Unlike pesticides that act as blind killers, or acoustic energy leaves essential ecosystem engineers like earthworms and soil microbes unharmed, allowing the terrestrial microbe to regenerate and restore soil health.
We have the prototype, the research, and the data to prove that it works.
It's time to move past chemical age.
EcoEco, rooted in the soil, protecting the world.
That was a powerful response to a global challenge. Our next finalist is Team Urban LPG from Strathmore University, Kenya, tackling Challenge 2, Resilient Cities.
Hello everyone, my name is Michelle Kishanga. I'm in a team that comprises of 4 people, Calvin, Simon, Esther, and myself. And our innovation is for engineering resilient urban LPG infrastructure. This particular innovation touches on SDG 11, which is on safety consideration as well as disaster management. And it also touches on SDG 9, which is about innovation and infrastructure. The motivation for our innovation was an incident that happened in our home country, Kenya, where at a gas refilling station, a pipe was left open, which led to a gas leak that caught fire and led to a huge explosion. This particular disaster led to the loss of 3 lives, as well as injuries to hundreds of people.
Current LPG safety infrastructure suffers from a fatal blind spot in low resource settings. First, there is the problem of the last meter gap. High-end industrial monitoring solutions exist for refineries, but are too expensive and complex for residential use. Homes rely on dumb mechanical regulators that cannot detect leaks or cut flow automatically. Second, there is cascading failure. In dense urban environments, housing units share walls. A fire in one unit places all neighbors at immediate risk of BLEV, that is, boiling liquid expanding vapor explosion. Current alarms are localized, they do not warn the community. Third, there is a reliance on human intervention. Traditional alarms require a human to be present and conscious to turn off the gas. If the user is asleep, absent, or incapacitated, the leak continues until ignition. The challenge is to engineer a low-cost, retrofittable system that autonomously isolates leaks and communicates threats to the wider community without relying on constant internet connectivity or human action.
To solve this at scale, we couldn't just find a gadget. We had to engineer a system. We developed the 3-tier engineering resilient urban LPG infrastructure. At the bottom layer, we have the edge node. This is the physical retrofit unit. We selected the ESP32 microcontroller as our brain because of its dual ability to handle safety logic and communication simultaneously. It reads data from an MQ6 sensor for gas density and a thermistor for heat. Crucially, we engineered this to be fail-safe. We use a normally closed solenoid valve. This means the valve needs active power to stay open. If the battery dies or wires are cut, the spring mechanically snaps the valve shut. The system defaults to safe in every failure scenario. Moving up to the network layer, we have the community gap. We know informal settlements often lack stable Wi-Fi. That's why we utilize the ASP.NOW protocol. This allows our devices to communicate peer-to-peer independent of the internet. If device A detects a leak, it broadcasts a high-priority packet delivery to device B and C within milliseconds. This creates a decentralized alert system, effectively turning a block of apartments into a single intelligent organism that reacts to danger instantly. Finally, the cloud layer. A gateway node aggregates the mesh data to a central dashboard. This gives us a digital twin of the infrastructure, allowing us to map leak hotspots and analyze consumption data for the SDGs. From solenoid valve to the city dashboard, this is a robust end-to-end engineering solution designed for the reality of the developing world.
It addresses a critical but overlooked risk in high-density urban areas, LPG fires. Today, a single gas leak can destroy entire neighborhoods. We transform LPG cylinders into intelligent systems that automatically shut off leaks and alert nearby homes in real time. By removing reliance on human reaction and internet access, we stop fires before they spread, protecting lives, homes, and building safer, more resilient cities.
After seeing our project, we can conclude that our innovation provides monitoring, communication, and preventive measures by implementing smart infrastructure. Thank you very much. This has been our preview.
And last but not least, another exceptional piece of innovation. We have Think from American University of Sharjah, the United Arab Emirates, tackling Challenge 2, Resilient Cities.
Extreme heat is one of the most critical and recurring challenges faced by cities in the United Arab Emirates. During summer months, temperatures frequently exceed 45 degrees Celsius, causing electricity demand to spike sharply. The primary reason for this surge is air conditioning, which becomes essential for daily life, public safety, and productivity. This places significant stress on the power grid, increasing carbon emissions and reducing the overall resilience of urban energy systems. A major and often overlooked issue is how inefficiently electricity is used within existing urban infrastructure.
A major contributor to this inefficiency is conventional streetlights. Streetlights operate every night at full brightness, regardless of traffic density, pedestrian movement, or lighting conditions. Even when the roads are empty, the lights are completely on. In a city like Dubai, with thousands of streetlights operate simultaneously, this creates a constant and unnecessary electrical load, exactly when the grid is already under stress due to cooling demand. Now this raises an important engineering question. Can existing city infrastructure be redesigned in such a way to reduce energy waste and support cities during extreme heat? Why streetlights? We chose streetlights deliberately. Streetlights are already deployed at a massive scale and they are government-owned and centrally managed. They are structurally ideal for mounting solar panels, sensors and electronics, and they are directly connected to the city's energy network. Yet today, they are passive electricity consumers. They do not think, adapt or respond to real-world conditions. Our idea is simple but powerful. Transform streetlights from passive loads into intelligent systems that actively support cities during extreme heat.
Streetlight integrates a compact solar panel mounted at the top of the pole. The panel has dimensions of 0.66 meters by 0.4 meters, giving an area of 0.264 square meters. Assuming 20% panel efficiency and average UAE solar conditions of 5.5 peak sun hours per day, the daily energy generated is approximately 0.25 kilowatt hours per day. This energy is generated during daylight hours when streetlights consume almost no power.
To complement solar energy, each streetlight also integrates a vertical axis wind turbine designed specifically for urban environments. Unlike traditional turbines, vertical axis turbines can operate under low, turbulent, and multi-directional airflow, making them suitable for roadside conditions. The turbine uses a helical blade geometry, which enables smooth rotation, reduced vibration, and low noise. Although ambient wind speeds may be low, passing vehicles generate repeated airflow disturbances. Using a conservative effective wind speed, the turbine produces approximately 0.08 kilowatt hours per day.
Light uses a realistic sensor set, nothing excessive, nothing impractical. A motions or a presence sensor similar to those used in automatic doors and smart lighting systems is mounted just below the lamp head, approximately 3 or 4 centimeters above the ground and angled slightly downwards. This allows it to detect pedestrians, cyclists and vehicles over a radius of 8 to 12 meters, covering both the sidewalk and the roadway. An ambient light sensor no longer than a few millimeters is placed on the top or the side of the lamp head. It faces the sky and is positioned so it is not affected by the lamp's own light, allowing accurate detection of daylight and dusk conditions.
A temperature sensor, roughly the size of a matchstick head, is mounted mid-pole inside a ventilated casing on the shaded side of the streetlight. This prevents direct solar heating and also ensures that it measures true ambient air temperature, not just surface heat. Optionally, a small internal rotation sensor is placed inside the wind turbine housing to monitor turbine activity. This sensor is fully enclosed, protected from dust and rain, and has no visual impact. All sensors are compact, low cost, and are already widely used in existing urban systems. Data from these sensors is processed by an AI-driven energy management layer. Rather than reacting in real time, the system becomes predictive. It analyzes traffic patterns, temperature trends, lighting demands, and the stored energy levels. For example, if extreme heat is forecasted, the system will conserve energy earlier in the day. Streets with low night activity are dimmed proactively. Stored renewable energy is released strategically during the peak cooling hours. The entire system was designed, modeled, and animated in such a way using computer-aided design and 3D modeling tools, allowing feasibility to be re-evaluated before physical deployment. This project directly contributes to SDG 7, Affordable and Clean Energy, and SDG 11, Sustainable Cities and Communities, and SDG 13, Climate Action. Extreme heat is no longer a future threat. It's a present reality for the cities in the UAE. Resilient cities are not built only by generating more energy, but by using energy intelligently. By redesigning streetlights as smart, renewable, and AI-driven infrastructure nodes, our solution demonstrates how engineering can transform everyday urban systems into powerful tools for climate resilience and sustainability.
We extend our sincere thanks to our distinguished judging panel for their time, expertise, and commitment to recognising emerging engineering talent.
The judging process included first-stage evaluations from judges around the world, followed by a second-stage review and a deliberation meeting. We are deeply grateful to all our judges for their dedication under a very tight time frame. We have acknowledged their contribution by listing them on the World Engineering Day website. Check it out. Congratulations to all our finalists. Your ideas demonstrate that engineering and digital innovation are powerful tools for building a more sustainable and inclusive world.
Thank you to everyone who participated, judged, and supported us for this year's hackathon. We look forward to continuing this global journey of innovation together. And happy World Engineering Day for 2026.